Hi everyone, this is Mrs. Eggerding and you're watching Unit 3, Video 8, and we're going to talk about the discriminant of quadratic equations. You guys are familiar with the quadratic formula, and the quadratic formula, as you work with it, you start to realize that a lot about your solution depends on what's happening inside that radical. And this is the part that we call the discriminant. Just the b squared minus 4ac. And this discriminant can help us describe the solutions that we're talking about in a quadratic equation. So, for example, if we have a discriminant value that is negative, in other words, I'm taking the square root of a negative number. That tells me something about the type of solution that I have. And it tells me I'm going to have an imaginary solution because I'm taking the square root of a negative number. And it also tells me how many of them I have. So it talks about the number of solutions. And in this case, it's going to be two imaginary solutions, and in fact, these two are what we call complex conjugates. If we have a discriminant that has a value of 0, in other words, we're doing the opposite of b plus or minus the square root of 0 over 2a. Square root of 0 is 0, so what that means is I'm only going to end up with one solution. And that one solution will be a real solution. And better than real, it's also going to be a rational solution. And in fact, that solution will be the opposite of b over 2a. It will be the vertex. And that tells me I have one x-intercept. It's the vertex, and it is on the x-axis. Last possibility is if my discriminant is positive. If my discriminant is positive, I am going to have real solutions. I will have two of them. But I can break this down a little bit more, and I can actually describe if my real solutions are rational or if my two real solutions are irrational. And that depends on if this positive number is a perfect square or not. If it's a perfect square like 5 or 49, I'm taking the square root of a perfect square. It's going to give me a whole number, makes my solution rational. If it's not a perfect square, I won't be able to simplify that square root to a nice number, and my solutions are going to be imaginary. So that's the information you need to be able to describe solutions. Let's take a look at some problems. Directions are going to say describe the solutions, or they'll say describe the number and type of solutions using the discriminant. So here's 5x squared minus 2x minus 4 equals 0. You start by looking at the b squared minus 4ac. And in this case, negative 2 squared minus 4 times 5 times negative 4. That's going to be positive 80, so I'm going to get 84. It is a positive number, so I'm going to get two real solutions. 84 is not a perfect square, so my two solutions are going to be irrational. So the description is two real solutions, and they happen to be irrational. Next one, x squared minus 10x equals negative 25. I'm going to put it in standard form first, just like you would if you were going to actually solve with the quadratic formula. My discriminant is b squared minus 4ac, and so I get negative 10 squared minus 4 times 1 times 25. That's 100 minus 100. That's 0. That tells me I have one real solution. That's my description. It also happens to be a rational solution. And this one is actually pretty easy to factor. It is x minus 5, x minus 5. My one real solution is x equals 5. It's the vertex, and it's going to be on my x-axis. So here's the last one. 2x squared plus x plus 4 equals 0. My discriminant is b squared minus 4ac. That's 1 squared minus 4 times 2 times 4. That's 1 minus 32. Negative 31. My discriminant is negative. It's going to get me 2 imaginary solutions. There's the description. And in fact, these solutions are going to be what we call complex conjugates. And this is pretty much all your homework is going to ask you to do. You will be asked to calculate the discriminant and then describe the solutions based on that answer. Couple questions on it, page 125, 71 to 79 odd. We'll talk to you soon.